Good morning viewers. In this session, let us concentrate our interest on solving few problems on the different chapters so far we discussed. As you all know, problems are the skeleton of the subject. So, it indicates that if you are in a position to solve the problems comfortably, definitely it indicates you may have a very comfortable relation with the subject. That is why understanding the problems is very important for a student. From the examination point of view also, you are going to solve few problems in your forthcoming examination. So, there each problem is awarded for 2 marks, 3 marks, and also some problems are there for 5 marks. To get 5 marks, so if you understand the problem in a well defined manner, you can find the correct solution within 3 to 4 steps. If you did those 3 to 4 steps correctly, definitely you will get 5 marks. At the same time, to get 5 marks in the theoretical part of a question, that is describe an experiment or the derivation which is in the form of prove that so and so, write a short note on so and so, at least you have to spend one complete page for that. That is the power of the problems to get the good lot of marks. That is why concentrate more on the problems to get a good lot of marks at the same time. So, if you solve the problems comfortably, it indicates that you may understand the subject comfortably also. So, today I just made a small attempt to solve few problems on your different chapters which are already given in the previous examinations. Let us start our discussion with the first problem, which is also asked in the previous examination. The least count of the vernier calipers is 0.005 centimeter. If the main scale is divided into half millimeter, calculate the number of divisions on the vernier scale. The thing is, first, before going to start the problem, you just scan the problem. So, here the question required is, it is required to find how many divisions are there in the given vernier calipers. So, what data is given in that calipers? The least count is 0.005 centimeter, and in that calipers the main scale is divided into half mm. So, the summary is, we are going to find how many divisions are there on the vernier scale of the given calipers. So, where in that the least count of that calipers is 0.005 centimeter and main scale of that calipers is divided in terms of a half mm. The main scale is divided into half mm means the value of each division on that main scale is half mm. So, the given data is also you can write in the form of value of 1 MSD, which is equal to half mm, which is nothing but a 0.5 mm, or you can convert it into centimeter, it is 0.05 centimeter. So, our number of VSD is equal to what? So, how many number of VSD vernier scale divisions are there in that calipers? So, we know that by definition, so least count in case of a vernier calipers is a ratio from value of 1 MSD to total number of VSD. Right. So, least count it is that is least count is 0.05 centimeter, value of 0.005 centimeter it is. So, value of 1 MSD is 0.05 centimeter. Now, it is required to find how many number of VSD are there. So, just cross multiply it, number of VSD, which is equal to 0.05 divided by 0.005 centimeter. Note that both are in the same unit. So, you can rewrite this one in the form of 5 into 10 power minus 2, because decimal place is shifted to 2 more position. So, by following the same convention, you can rewrite the denominator as 5 into 10 power minus 3 centimeter. This 5 gets cancels with this 5. So, the numerator is 10 power minus 2. When the denominator goes to the numerator, 10 power minus 3, it will become a 10 power plus 3. When bases are same, power must be added. It is minus 2 plus 1, it is plus 1. So, therefore, number of VST in that calipers is 10. This is the answer. So, in the question, how if the in a given calipers its least count is 0.005 centimeter, then that in that calipers the main scale is divided in half mm, then how many vernier divisions are there is the question. Now, the answer is, in such a vernier calipers, number of divisions on the vernier scale should be 10. So, number of VSD should be 10. So, in this way you have to write the answer for that problem. So, now move on to the second problem. The second problem is, how would you construct a vernier to read correct to 0.005 centimeter for a main scale which is divided in mm. Again, you have to scan there comfortably what is given. So, what is required? If you understand those two topics, the 50% of your job is over. He says that how would you construct a vernier scale in a given vernier calipers such that in that vernier calipers, so that instrument is able to read up to 0.005 centimeter, means that itself is a least count of that vernier calipers. You have to take here 0.005 centimeter as a least count, where the main scale is divided in mm means, so value of 1 MSD is 1 mm. You just compare this convention with the previous problem where the main scale is divided in half mm. That is why there we are taken value of 1 MSD is 0.5 mm. Here the main scale is divided in mm means value of 1 MSD is 1 mm. So, value of 1 MSD is 1 mm. So, in different fashion, so this problem is asked when compared to the previous problem. So, what you have to require to find is, so to have a such a calipers, which is read correct up to 0.005 centimeter whose main scale is divided in mm. So, how many divisions of your vernier scale should contains? In different way he expecting. So, in such a vernier calipers having these characters should contain how many divisions on the vernier scale. So, once again you just recall the least count of the vernier calipers. So, you substitute the required given data. Least count is again 0.005 centimeter, value of 1 MSD is 1 mm, or you can rewrite this one as 0.1 centimeter divided by total number of VSD. So, again number of VSD, you just cross multiplied it, 0.1 divided by 0.005 centimeter. So, 0.1 you just write it as a 1 into 10 power minus 1. So, now you can rewrite this one as 5 into 10 power minus 3, right. So, here it is 1 by 5 into 10 power minus 1. When it goes to the numerator, it becomes 10 power plus 3. So, minus 1 plus 3, it is gives the 10 square by 5. 10 square means 100 divided by 5. 5 ones are 5 twos are. So, number of VSD in such a vernier calipers is 20. The summary is, to have a vernier calipers to read up to 0.005 centimeter whose main scale is divided in millimeter. So, the number of divisions on such a vernier caliper should be 20. So, in this fashion you have to solve problem of this kind. Now, move on to the third problem. So, let us see what is there in the third problem. So, we will move on to the next slide. So, watch the slide carefully. First, scan the problem. So, from the problem, collect what data is given, and also you should understand from that, for that problem, what is a required solution. So, the problem says the main scale is divided in half mm. The main scale is divided in half mm means the value of one division on the main scale is half mm, that is 0.5 mm. So, 0.5 mm means 0.05 centimeter. Then the length of the vernier attached to it is 12 mm long and is divided into 25 equal parts. So, concentrate here. The length of the given vernier scale is 12 millimeter long. In that 12 millimeter length, there are 25 equal divisions are marked by following the principle of vernier. That is, so 12 mm length should be equivalent to 25 vernier scale divisions. 12 mm is equal to 25 vernier scale divisions. Now, the thing is, calculate the value of 1 MSD. Calculate the value of 1 MSD. Value of 1 MSD is equal to what? Then, and the least count of the given instrument. This is the question. Calculate the value of one vernier scale division, sorry. So, here the calculate the value of one vernier scale division, because value of 1 MSD is given. So, at the same time it is required to find least count of the vernier. So, understand the problem. There is a vernier calipers where the main scale is divided in half mm. So, the length of that vernier calipers is 12 mm long. So, this 12 mm vernier scale contains 25 equal divisions. Now, what he expects is, what is the value of one division on the vernier scale? Then, what is the least count of that vernier calipers? So, from the given data itself, you can find the value of 1 VSD very easily, because 12 mm is equal to 25 VSD means, so by cross multiplying it, you can write 1 VSD is equal to 12 by 25, right. So, you can divide 12 by 25, 0.4. So, 25 8s the 200. So, 1 VSD is equal to 0.48. Of course, practically speaking, it does not possess us the unit, but here 12 mm long is given. Therefore, you can write 1 VSD is equal to 0.48 mm. So, if we know the value of 1 VSD and also value of 1 MSD, the least count of the vernier calipers can be found very easily by using the basic definition of the vernier calipers least count. So, I will say, while discussing the vernier calipers, the least count of the vernier calipers can also be defined as the difference between value of one main scale division and one vernier scale division. I mean, least count can also be given as value of 1 MSD minus value of 1 VSD. What is the value of 1 MSD? It is given, it is 0.05 centimeter. Minus what is the value of 1 VSD? We found it 0.48. So, you can rewrite this one as 0.048 centimeter, because this is in centimeter, that should be also in terms of centimeter. 0.48 centimeter and 0.5, then you can rewrite, you can find the difference, it is 0.002 centimeter is the least count of the given vernier calipers. For a calipers whose main scale is divided in half mm and 12 mm of that vernier scale contains 25 vernier scale divisions, in such a calipers value of 1 VSD is equal to 0.48 mm and least count of such a calipers is 0.002 centimeter. This is the solution for this problem. It is also given in the previous examination. Now, let us move on to the next problem. So, go through the next problem. In a slide calipers, the main scale is divided into half mm. Main scale is divided into half mm means value of 1 MSD is equal to half means 0.5 mm, or you can convert it into centimeter, it becomes 0.05 centimeter. Then the 19th MSD coincides with the 20th VSD. The 19th MSD coincides with the 20th VSD. I mean, there is a problem in the problem. 19th MSD coincides with 20th vernier scale division. On gripping a solid cylinder to find its length, the MSR and CVD are 11.5 centimeter and 8 divisions respectively. So, MSR here it is, so 11.5 centimeter and CVD is given 8 divisions. Now, if what is the length of the given object? So, what is the length of the given object means you can find the total reading to find the length. In case of the vernier calipers, the total reading can be given as total reading is equal to MSR plus CVD into LC. So, MSR is given and CVD is also given and it is required to find the least count. So, we know that value of 1 MSD divided by number of VSD is a, so least count of the given calipers. Here the problem is not very much clear. Imagine that there are 10 vernier scale divisions are there. There are 10 divisions on the vernier scale. To find the least count, so write the formula again, least count is equal to value of 1 MSD. How much is the value of 1 MSD? It is 0.05 centimeter divided by number of VSD. Number of VSD it is 10. So, by following the previous convention, you can solve it. 5 into it is 10 power minus 2 divided by 10. So, when it goes to the numerator, it is 5 into 10 power minus 3 centimeter is the least count. So, now coming to what is the MSR here? MSR is 11.5 centimeter plus CVD is 8 divisions into least count is 5 into 10 power minus 3. Now, it is 11.5 plus, so 8 into 0.005. So, I mean 10 power minus 3 you have to multiply it with 5, 10 power minus 1 minus 2 minus 3. Now, this is 11.5 plus 8 5s are 40, 0.04. So, by adding these two you can write 11.54 centimeter is the length of the given objects. So, in this way you can find the length of the given object. So, now let us move on to the next problem. The least count of a vernier calipers given is 0.01 centimeter. So, here directly least count is given. So, what is given? You just collect from the given problem. The least count of the given calipers is 0.01 centimeter. In setting, the 0 of the vernier scale lies between 1.6 and 1.7 centimeter. In setting, 0 of the vernier scale lies between 1.6 and the 1.7 centimeter. The thing is, so while studying the concept of the how to take the reading in case of the vernier calipers, when the object is firmly gripped, the 0th division of the vernier scale coincides with which division on the main scale is the convention to take the main scale reading. Here it says that when the object is gripped between the fixed jaw and the movable jaw, the 0th division of the vernier scale lies between 1.6 centimeter and 1.7 centimeter. So, if you face such a practical situation, the convention we followed is out of those two, which is the lowest number, you have to take that one as a main scale reading. So, the 0th of the vernier scale lies between 1.6 and 1.7 centimeter means 1.6 centimeter is the lowest division. Therefore, you have to take main scale reading as 1.6 centimeter. I mean the given main scale reading is equal to 1.6 centimeter, and the 8th division of the vernier scale coincides with the main scale. So, CVD is given, it is 8. Then what he expects is calculate the total reading. It is almost analogous to the previous problem. There we are finding the least count of the calipers also. Here the least count is given, MSR is given, coinciding vernier is given, and required to find the total reading of the instrument. Once again recall the equation which is used to calculate the total reading in case of the slide calipers. It is MSR plus CVD into LC. So, how much is MSR? It is 1.6 centimeter. How much is CVD? It is 8 divisions. So, what is the least count of the instrument? 0.01 centimeter. So, care should be taken, the MSR and the least count should be expressed with the same unit. Sometimes what mistakes done by the students in the examination is, he is writing the MSR in terms of the millimeter, but least count in the centimeter, and vice versa is also they are taken. So, if you are interested to calculate the total reading in terms of a millimeter, take MSR in terms of millimeter and simultaneously least count also in terms of a millimeter. So, if you want to solve it in terms of a centimeter, so MSR should be in centimeter and least count is also in centimeter. Now, do the rest of the work. So, it is 1.6 plus 0.08 when we multiply 8 with 0.01. By adding these two, you will get 1.68 centimeter is the total reading. Observe here, for only these 3 steps, you will get 5 marks in the examination. To get 5 marks from the theoretical part, you have to write so lot more things to get a 5 marks. That is the intention of show some interest on solving the problems. Problems are, these are all the problems given in the examination itself. See how much they are simple. So, move on to the next problem. This is the problem on screw gauge. In a screw gauge, the sleeve is advances by 5 millimeter for 5 rotations. If there are 100 HSD, calculate the least count of the screw gauge. So, first try to decide here, it is required to find least count of the given screw gauge. So, this is the question. To have an answer for this question, you should write the equation used to find the least count of the calipers. So, how can you write the least count in case of the screw gauge? Least count can be defined as a ratio from pitch to the number of head scale divisions, right? Number of head scale divisions is then the denominator, pitch is there in the numerator. It says that the sleeve of a screw gauge moves by 5 mm when we give 5 rotations. You have to understand here in a manner such that when we give the 5 rotations to the head of the screw, I repeat, when we give the 5 rotations to the head of the screw, there 5 mm is the distance uncovered on the pitch scale. So, to find the least count, you should know what is pitch. So, what is given means, so distance uncovered on the pitch scale or distance covered on pitch scale is 5 mm. So, this amount of distance is uncovered on the pitch scale only when number of rotations given to head is 5. Is it clear? By using this data, you can calculate the pitch. Therefore, pitch, it is a ratio from distance uncovered on the pitch scale. How much is the distance uncovered? It is 5 mm to the number of rotations given to the head. How many rotations we are given to the head of the screw? 5. These two gets cancels. Therefore, you can write pitch is equal to 1 mm. Now, coming to the original part of the question, what is the least count of such a screw gauge? Least count is equal to pitch is 1 mm. So, number of head scale divisions. Here it is informed that if there are 100 HSD means in such a screw gauge there are 100 divisions on its head scale. Number of divisions on the head scale is 100. So, you just simplified 0.001 mm. 0.001 centimeter, I think 0.01 mm, 0.001 centimeter it is. So, in this way you are going to find the least count of the given screw gauge. So, once again for this question the marks awarded are 5. So, move on to the next question. A screw gauge has a pitch of half mm. So, observe here pitch itself is given directly. The screw gauge has a pitch. I will say while explaining the concept of the screw gauge, usually pitch of a screw gauge is equal to value of one division on its pitch scale. Is it clear? You have to remember that one. A screw gauge has a pitch of half mm. So, that is 0.5 mm. And 50 divisions on its sleeve, I mean number of HSD is equal to 50. The reading when the jaw touch is 5 divisions plus 5 divisions, I mean the reading when the jaws touch is plus 5 divisions means when the movable tip of the screw comes in contact with the stud or fixed plug, the fifth division of the head scale coincides with the pitch line. So, 0 error is plus 5 instead of coinciding 0th division, 5th division of the head scale coincides with the pitch line. Therefore, here 0 error is equal to plus 5 HSD. So, consequently, 0 correction is minus 5 HSD. So, move on to the next part. When gripping a wire, the reading is 3 turns and 17 divisions. So, when gripping a wire, the reading is 3 turns and 17 divisions means, so for each turn one division should be uncovered on the pitch scale. The value of one pitch scale division is 0.5 mm. 3 turns means 3 into 0.5. So, therefore, you can say PSR is equal to 3 into 0.5 means it is 1.5 mm. Then, so 17 divisions on the head scale, I mean head scale reading is 17 HSD. So, it is required to find so diameter of the wire. Diameter of the wire means, so from writing the total reading equation only you are required to find the diameter. So, the confusing part is when gripping a wire, the reading is 3 turns and 17 divisions. 3 turns means, so you may observe 3 divisions on the pitch scale when you are giving the 3 rotations to the head. The value of one pitch scale division is 0.5. Therefore, in this case it is a special case, pitch scale reading you have to taken as a 3 into 0.5. If it is a 5 turns and something, it is 5 into 0.5 like that. So, again recall what is the least count in case of a screw gauge. Least count is equal to pitch divided by number of HSD. Again pitch is 0.5 mm, the number of head scale divisions is 50. Zero 0.01 mm is the least count of the given screw gauge. Now, the diameter of that wire is calculating by writing the total reading of that screw gauge. It is PSR plus HSR plus or minus ZC into LC is the equation used to find the total reading. Pitch scale reading is 1.5 mm, head scale reading is 17, 0 correction is it is minus, therefore plus or minus is there, you have to write minus 5 into LC is 0.01. Once again care should be taken such that pitch scale reading and least count should be expressed with the same unit. So, pitch scale reading is 1.5 mm, least count is 0.01 mm. Now, it is a time for simplify it. 1.5 plus 17 minus 5 means 12 into 0.01. So, it is 1.5 plus 0.12 it is, right. So, now it is 1.62 mm is the diameter of that wire, or even you can convert this in terms of the centimeter. 0.162 centimeter is the diameter of such a wire. So, this is how it is find the diameter of the given wire. These are the few problems. So, every time at least one problem may be expected in the examination on measuring instrument usually. So, so far given such a simple problem. So, in addition to these problem, if you work out some problems on the same chapter in different books, you can have a clear idea about the problems on the measuring instruments. Now, move on to few problems on the force and linear motion. Observe one of the problem which is given in the examination. A body is dropped from a height of 490 meter. Find the time it will take to reach the ground. The concept is there is a body, so which is dropped from a height of 490 meter above the earth surface. So, if you drop such a body, so definitely it will reach us the ground. Now, the thing is to reach the ground, how much time it will taken. So, what is the given data you have to first collect. So, a body is dropped from a height of 490 meter means height is nothing but a distance, length, it is 490 meter. So, when the body is moving towards the earth surface, its velocity goes on increases at every instant, we know according to acceleration due to gravity. So, here its velocity increases means initially its velocity is 0. Then when it moves towards the earth surface, its velocity increases means its velocity changes. So, changes means it should have a acceleration. Here velocity changes because of the gravity, therefore, acceleration possessed by a body in such a case is nothing but a acceleration due to gravity. Here acceleration of a body is nothing but a acceleration due to gravity. You have to take on this one as plus g because the body is moving towards the earth surface. We know that its value is 9.8 meter per second square. Later on, so find the time it will take to reach the ground. So, how much time it will take to reach the ground? Time it is required. So, A is there, S is given. So, T is required, U is known fact. V square is equal to U square plus 2AS. So, V is not given. S is equal to ut plus half at square. Definitely from that equation you can find the time. S is equal to ut plus half at square, but here it is gt square because acceleration is nothing but a acceleration due to gravity. It is even plus gravity because the body is moving towards the earth surface. So, that is how much is S? S is 490 meter. So, U is 0, T is required to find plus half into G is 9.8 and it is required to find T square. 490 which is equal to 0 into anything is 0 plus it is 4.9 into T square. So, 9.8 divided by 2 is 4.9. So, now that is 490 is equal to 4.9 T square. Therefore, T square is equal to 490 divided by 4.9. So, you can write 490 as 49 into 10, 4.9 as 49 into 10 power minus 1. This 49 gets cancelled. So, when 10 power minus 1 moves to the numerator, it becomes 10 power plus 1. So, 10 into 10 it is 100. T square is equal to 100 means T is equal to 10 seconds. The thing is, when you drop a body from a height of 490 meter, then it consumes 10 seconds to reach the ground. So, in this way we are finding the time required by the body which is dropped from a height of 490 meter above the earth surface. So, move on to the next problem. A body is moving with a uniform acceleration. And then what is given? Describes 10 meter in the third second. So, describes 10 meter in the third second means you just recall equation to find the distance travelled by a body during nth second of its motion. Distance travelled by a body during nth second of its motion is Sn is equal to u plus a by 2 into 2n minus 1. So, S suffix n indicates the distance travelled by a body during nth second of its motion. He says that 10 meter is the distance described by a body during third second of its motion means here S3 is equal to 10 meter. S3 is equal to 10 meter. So, in this equation replace n by 3 to get distance travelled by a body during third second of its motion. So, that is S3 is equal to u plus a by 2 into 2 into 3 minus 1. So, S3 that is S3 is given. So, S3 is 10 meter, 10 meter is equal to u plus 2 into 3 is 6, 6 minus 1 is 5, this is 5a by 2, call this one as equation 1. and 36 meter in the 5th second means distance travelled by a body during 5th second of its motion is 36 meter. Now, in the original equation replace n by 5 to get distance travelled by a body during 5th second of its motion. So, that is what you will get is S5 which is equal to u plus a by 2 into 2 into 5 minus 1. So, that is S5 means it is 36 which is equal to u plus 2 5s are 10, 10 minus 1 is 9, it is 9a by 2. Call this one as equation 2, right. So, equation 2 minus 1, what you will expected is calculate the acceleration. What is the acceleration possessed by the body? So, you have to understand the question in a well defined manner. There is a body which moves along a straight line with a uniform acceleration. Such a body describes 10 meter in its 3rd second and 36 meter in its 5th second. Then what is its acceleration? So, by applying the given data, we have the two equations. So, now to get the value of A, subtract equations one from the other. For the simplicity, so I will make equation 2 minus equation 1 gives, what is the RHS of the equation 2? It is 36 minus, what is the RHS of equation 1? It is 10, which is equal to, what is the LHS of equation 2? It is u plus 9a by 2 minus of, what is the LHS of equation 1? It is u plus 5a by 2. So, by multiplying the minus it becomes minus, it is also becomes minus, plus u minus u gets cancels, 36 minus 10 it is 26 which is equal to 9a by 2 minus 5a by 2. So, observe here minus into plus it is minus. Now, 26 is equal to, take 2 as the LCM, it is 9a minus 5a. So, cross multiply the 2, 26 into 2 which is equal to 9a minus 5a, it is 4a. Therefore, a is equal to 26 2s are 52 divided by 4. So, 4 1s are 4 3s are. Therefore, uniform acceleration of such a body is 13 meter per second square. To describe 10 meter in its 3rd second and 36 meter in its 5th second of its motion, that body moves with a uniform acceleration of 13 meter per second square. So, this is also the problem asked in the previous examination. So, move on to the next problem. A car changes its speed from 36 km per hour to 72 km per hour in 4 seconds. What is its acceleration? A car which is in motion, so whose velocity is increases from 36 km per hour to 72 km per hour in 4 seconds. So, what is given, you just write down. So, 36 km per hour you have to take it as a initial velocity, u is equal to 36 km per hour. So, final velocity v is equal to, it is 72 km per hour. So, in what time this change has been taken place is, it is by consuming a time of about 4 seconds. So, what is required to find is, find the acceleration possessed by the body. So, first it is 36 kilometer per hour, it is a velocity. In SI system, it should be there in terms of the meter per second. So, 36 kilometer means 1000, that is 10 power 3 meter per hour means 1 hour it is 60 minute, 1 minute it is 60 second. Now, it becomes meter per second. So, observe here 36 kilo means 10 power 3 per hour means 60 minutes, each minute is 60 second, therefore, it becomes meter per second. Now, you can rewrite this one as 36 into 10 power 3 divided by 60 can be replaced by 6 into 10, again it is 6 into 10. So, this 10 cancels with 10 power 3, 10 is remaining, 6 1s are 6 3s are 6 gets cancels. Only thing is 10 meter per second is its initial velocity. Same convention should be followed to convert the final velocity in terms of a meter per second. It is 72, kilo means 10 power 3, hour means 60 minute, 1 minute is 60 seconds. Now, it is in terms of meter per second. Now, this is 72 into 10 power 3 divided by again 6 into 10, 6 into 10. These two 10s cancels with the 10 power 3, 10 is remaining. So, 6 1s are 6 2s are 6 1s are 6 2s are. This is 2 into 10 which is 20 meter per second. Now, to find the acceleration, it is a rate of change of velocity. I mean change in velocity divided by time taken. Change in velocity means final velocity minus initial velocity divided by time taken. The final velocity is 20 meter per second, initial velocity is 10 meter per second, time of time consuming by the body is 4 seconds. 20 minus 10, it is 10 divided by 4. 4 2s are 4 5s are. So, it is 2.5 second has been taken by a car to increase its velocity from it is an acceleration 2.5 meter per second square is the acceleration gained by the car when its velocity is changes from 36 kilometer per hour to 72 kilometer per hour. So, in a time of about in a span of about 4 seconds. This is also a problem asked in the examination. So, move on to the next problem. So, okay, time is over. So, in the next class, I will continue the discussion on these problems in the rest of the concepts. So, from the today we stop our discussion at this level. Thank you.